Okay, so in the last lecture, we have seen about the Laplace transform, Fourier series, and the complex analysis. So, in this session, we'll start with the next topic, that is statistical techniques. Okay, so these techniques are very useful in data analysis, in understanding the data. And now data analysis or data science or data big data, these are very commonly used terms. So everybody is trying to get into this. And here what we are doing is we are trying to analyze the data. Okay, so we need to understand some basic techniques that can be applied to the data and to get the conclusion out of it, or we need to understand what the data says. Okay, now uh, suppose we are having a company. Okay, we are having a company with some products. Okay, and then we have two dealers. Okay, so dealer A and dealer B. So we are sending our goods to the market through these two dealers. Okay, so both the dealers are very important for us. Now the question is, dealer A is working with us since the last 10 years, and dealer B is working with us since the last 3 years. Okay. Now the turnover of this dealer A and dealer B is same. Okay, so whatever the company is getting from this dealer A and dealer B, they are giving us the same sales. So in terms of revenue generated from this dealer A and dealer B, we are having both equal. Yeah, so because dealer A is giving us the same amount generation and the dealer B is also giving us the same revenue generation. Now, the problem is dealer A claims more discount from our company as he is with the company since last 10 years. Okay, but the dealer B also says that I want more discount because I am giving the same sales as the dealer A is giving. Okay, so it becomes difficult for us. Correct. See, if we see the revenue wise, both the dealers are equal. If I see the claim of the first dealer that he is with us for 10 years, so obviously he should get a benefit. But if I think logically, the dealer B is giving us the same sales, so he is also important. And then the dealer B says that I am giving you the same sales within 3 years as the dealer A is giving you in 10 years. Okay, so his claim is also right. And now the question is to whom we should give more benefit. Okay, so that's a question that we want to answer. Okay, uh, if I give on the basis that dealer A is with us for 10 years, then dealer will be may not be with us. He will leave us, and then our revenue generation will be directly half. Okay, because both have the same sales, and we don't have the third dealer. Okay. Now the next thing is, if we consider the dealer B's demand and give more benefit to dealer B, then the dealer A who is working with us from last 10 years, he will not be with us, and so we have to be careful in either situation. Okay. Now the question is how we are able to convince both of these dealers. Okay, and the decision, our decision should be such that it will not offend anyone or it will not give benefit to anyone. Okay, so we have to consider both the dealers' demand, and then we have to consider their sales also, their experience with us also. Now, what is the tool that will give us the answer? Okay, so the name of the tool is correlation coefficient. Okay, so this is the tool which gives us the answer coefficient of correlation. Now, consider the another example. Okay, so all of us go shopping. Okay, we visit mega stores also sometimes. Like we have Big Bazaar, we have D-Mart, or we have Hypercity. Okay, so all these stores we usually visit and buy our goods. Okay, or let it be. Okay, so any shop which has all the necessary goods in it. So starting from grocery, uh, clothes, then accessories, then all the things that we require, the fast food and the frozen food and everything. Yeah. Now, the question is when you visit such kind of stores, okay, the stores salesmen or the employees approach you for their membership cards, and they say that you will have a benefit of the membership card. You will have say 5% to 15% discount every time you purchase from our departmental stores or our mega stores, and then you don't just have to give a initial amount of suppose 150 rupees or 300 rupees. Then we'll let you go with the card, and then you will have the benefit every time. And then we see that yes, there is nothing wrong in giving that 150 rupees and having the card and having the discount of 5% to 15% every time. Okay, and so we give our all the details like our mobile number. Now, mobile number has become the identity. Okay, so the mobile number and our email IDs and our details. Okay, and then we go on purchasing with the departmental store, and then we go on purchasing for a couple of weeks or twice in a week or twice in a 2 weeks or once in a month, whatever the frequency we have. So we visit that departmental store, and after your 2 3 visits, okay, suddenly you start getting messages from this departmental stores or their website or their customer care number that telling you that in so and so category, okay, we are having a nice offer. Okay, so we wonder why this fellow is sending me the messages related to this category only. Okay, so the answer is that they find or they analyze your shopping. Okay, back end when you purchase anything, when you visit the departmental store and then you purchase anything, and you have or you put your membership ID or you put your membership number or you tell your mobile number, and they will search your membership number and link that bill to your membership number or your account, and then after your 2 3 bills they start analyzing, and they will find out in which area or in which products you are mostly interested, you visit mostly, and you buy mostly. and then they start sending messages about that progress. Okay, so this they do using this statistical techniques or using this analysis. That's why uh, this module will be studying as a statistical techniques. Okay, so we can understand the data, the basics of the data science, data analysis. Okay, and this techniques can be extended to the number of variables. Okay, so as you visit the departmental stores, each product becomes your variable. Okay, and it is analyzed at that level. Okay, so here we'll see for two variables, but these techniques can be extended to the number of variables. Okay, so here we just try how it works, and then most of the times we do with the programming. Okay, so now you have to be careful and you have to calculate the things. Okay, so that's why I told you to have the calculators with you. If you don't have the calculators, please install a scientific calculator app in your Android phone, and then you can use it while our lectures. Okay, so first thing that we need to understand is what is the correlation. Okay, so we'll try to understand the correlation. First, the coefficient of correlation. So there are two types of correlations. One is the coefficient of correlations, which the first example I have taken of the dealer A and dealer B, and the second is the rank correlation coefficient, which test how good my decision is. So how good the decision is taken. Okay. So first will help us to take the decision, and second will help us to understand how good that decision is. And once it is a good one, we can go forward with that decision. Okay. So let us see how the decision is made, and then what this correlation of coefficient is. So the correlation of coefficient is also called as Karl-Pearson coefficient of correlation. Okay, so it is also called as Karl-Pearson coefficient of correlation. Okay, and the rank correlation is also named after the Spearman's. So it is called as Spearman's rank correlation coefficient. Okay, so first we'll see the Karl-Pearson coefficient of correlation. Okay. Okay, so we have first the Karl Pearson coefficient of correlation. So we have to be careful that we have this Karl Pearson coefficient of correlation. Okay, now we have we denote it by the numerical value called coefficient of correlation between x and y can be calculated by the formula. So we have this formula r is equal to n times. This is denoted by small r. Okay, so this is denoted by small r, and we have the formula for that. R is equal to n times summation. Please be careful for the capital letters and the small letters. So these are all small letters. Summation n times summation xy minus summation x into summation y, and upon square root of n times summation x square minus summation x its square, and here we have into square root of n times summation y square minus summation y and its square. So this is the formula we have, where n is the number of observation See here, what small x is? Small x is capital X minus x bar. X bar is the mean of x, and we have y is equal to small y is equal to y minus y bar, where x and y bar, y small x and small y are the mean deviations. So this is also called as mean deviation. So it is a deviation from the mean, and we are able to calculate the means x bar as summation x upon n summation capital Y upon n. So this is x bar and y bar. And now we'll consider this x bar and y bar as the integer. If not integer, we may round off to integer value. Okay, so we have this, and now if we want to apply this one, okay, so what we have to do is see here. If I want to calculate this r, I need to calculate what is x, what is y. Then I need to calculate what is going to be the n here. What is going to be the summation x square? What is summation x and its square? Okay, so these are the terms we have to calculate, and hence we have to make the table for this. Okay, and then we are able to solve the problems using this formula. So first, what we have to do is we just have to write what is the n. Okay, we need it. Then we have to calculate what is x bar. Then we have to calculate what is y bar, and then after calculating x bar and y bar, we are able to calculate small x and small y. And once we are able to calculate small x and small y, then we are able to calculate this formula. So first we'll write the formula, then we'll calculate the things one by one, and then finally we'll calculate the value of r, which will be the coefficient of correlation. So this is called the coefficient of correlation. Okay, so that's what we have to use. Now the question is, what is the maximum value and what is the minimum value of this coefficient of correlation? Okay, so we can have the maximum value and the minimum value is, okay, the value of r is between -1 and 1. So that is, we have -1 less than or equal to r less than or equal to 1. So what is the significance of this r value in between -1 and 1? So when we say r is equal to -1, so when we say r is equal to -1, that means the variables x and y are not related with each other in any case. Okay, and when we say r is equal to 1, that means the variables x and y are closely related with each other. So what you can say, the closely related variables. Suppose we have a price of the suppose a price of any commodity, and then we consider the quantity purchased by that commodity, and then what will be the bill amount? So bill amount will be proportional to the quantity purchased. Okay, and that's why the bill amount and the quantity, they are closely related. So if I have x is a bill amount and y is the quantity purchased, then x and y are the closely related. So in that case, you will have the value of r near to 1. Okay, and when we have the value to be -1, suppose the price of one commodity and the price of another commodity, and we observe these prices on daily basis, and we observe for the 7 days. Okay, so these two quantities are independent, and their price depends on their supply and their demand. And so in that case, you may have the negative coefficient of correlation. So that's why maximum value of r can be 1, minimum value of r can be -1. So r will be never less than -1, and r will be never greater than 1. Okay, so when you get any value less than -1 or greater than -1, then you have to check your calculations, that your calculations may not be correct. Okay, because we have the lower bound and upper bound for this value of r, so it is always -1 and maximum 1, and that's why we have to be careful while having the value of this r. So either it will be 100% correct or it will be 100% wrong. It may not be more than 100% or it may not be less than -100%. So that's why we have to be careful. Okay. Now let us try an example based on this. Okay. So this is the formula that we have, and then now we'll try to apply the formula to solve the example. So we have the first example. So this is the example. Please write it. Okay. So you can have compute the coefficient of correlation between x and y from their values given below. So these are the values given below, and now you have to calculate the coefficient of correlation. Again, so you can see here, this is the formula that we have to use, and we know the value of r is going to be between -1 and +1, and this is the formula. So now we have to solve this problem. Okay, so we'll go with the solution. Okay, so what is given? X and y quantities are given. So we can say let R be the coefficient of correlation. Correlation between X and Y. Okay, so between X and Y. So we have, what is the formula for R? So formula for R is n times summation xy. So you can see this formula. Okay, so n times summation xy, summation x, summation y. Okay, so you can have summation x into summation y on, here we have n into square root of n into x square summation x square. So we have square root of n into summation x square minus square of summation x into square root of n into summation y square minus summation y is square. Okay, where we can have, so we have to write each of this term what we have. So n is equal to number of observations, okay, or given observations. What is x? Okay, so small x is equal to capital X minus capital X bar, so which is mean deviation. This is called mean deviation. And small y, so it is capital Y minus capital Y bar. So mean deviation of capital X, and this is mean deviation of capital Y. Okay, so we got here that the formula we have written, what are the terms in the formula we have written. Now see what is the value of n. Count this observation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 pairs of observation. Okay. So we have 10 pairs of observation. So we can say here n is equal to 10. Okay, so it becomes easy. So we go on calculating the data one by one. And now I want to have x and y. So for that I have to calculate x bar and y bar. So we can write here, okay, and x bar is equal to, so I'll have so here I'll write, and x bar is equal to summation x upon n, y bar is equal to summation y upon n. Again, be the means of x and y respectively. So these are the means of x and y. Now we have here n is going to be 10. So now we consider the table. Okay. Now consider the following table. Okay. So what we can have is, okay, so we'll consider the table. Okay. So let us see what the table we have to consider. So we'll see one by one. What I have given, what is given to us. See, what is given to us? Given to us is x. Okay, and so I'll have the first column of x. Now, what is given to us? Y. Okay, so we'll have y here. And now, see, what do we want? We want next x minus x bar. So small x is equal to x minus x bar. And that's what I'll have here. Okay. Now, you can see we want next, we want small y is equal to capital Y minus y bar. So we'll have y bar here. Now we can see the formula. What do we want next? We want x into y, small x into small y. Then we want x square, small x square. Then we want small y square. Okay. So these are the terms we want. See, we want x into y, we want summation x, summation y, we want summation x square, and so we consider this table. Now we want these observations. Okay, so we have such 10 observations. So please draw the table. Now you have to calculating this. So we have to write all the observations here. Okay. So we can see what are the observations we have. See, this is 30, 33, 25, 10. Okay. So we can have 30, 33, 25. We have 10. Okay. Now what are the y values? 68, 65, 80, 85. So we have see the terms here 68, 65. So this is 68, 65, 80, 85. Okay. Please draw the enough rows and columns. Okay. Please draw this table properly so that we'll not miss any entries or we'll calculate everything properly. In the examination, you have to write this all like this only. Okay. Now can have. So see the next entries. What are the next entries we have? This is 33, 75, 40, and 85. Okay. So can have this 33, 75, 40, 45. Okay. 33, 75, 40, 85. 33, 75, 40, 85. What we have y entries. So we can see y is 70, 30, 55, 80. We have 70, 30, 55, 18. Yeah. Now you can see what we have 90, 95, 15, 10. Okay. So 90, 95, and this is what we have 15 and 10. Okay, so this is for the summation. Okay, that's what we have. Okay, so we have written the data, and now we have to calculate all these columns. Okay, so now from above table we have. Okay, so I hope you are calculating the values. So tell me what is the value. Yeah. So what is the value of summation x, summation y, and then these all values you have to calculate and give me. So I hope you are writing with me. So you have to calculate these values and give me. Tell me what values you are getting. Now you have to unmute yourself and then give me these values. Summation x is 516. Okay. Summation y is 496. Okay. So this summation you have calculated 516 and this is 496. Okay, that's what we have. Now once I know this summation, so what we are able to calculate is hence we get x bar is equal to summation x upon n. So we have this is 516 by 10. So we have already declared that here n is equal to 10. So we have declared this n is equal to 10, and hence this will be the term 51.6. So what will be having y bar? So it is summation y upon n. So here we got this is 49.6. Sorry, 496 by 10. So we can have this is 49.6. Okay. Now here, once I know that this value of x is 51.6 and the value of y bar is 49.6, so I can calculate these two tables. Okay, so please calculate these two tables and let me know what you are able to get. So you have to give me these values. So calculate these values and let me know what you are getting. So what we have here, so I hope you are calculating these values and get these values. Okay. So we want summation x, summation y, and we want all this remaining columns. So I hope you can get this value as minus 21.6. Okay. And this is minus 18.6. This is minus 26.6. This is minus 41.6. This is again minus 18.6. This is 23.4. This is minus 11.6. This is 33.4. This is 38.4. This is 43.4. Now the sum of this. So till that we'll calculate this table. So this is 18.4. This is 15.4. This is 30.4. This is 35.4. This is 20.4. This is minus 19.6. This will be 5.4. This will be minus 31.6. This is minus 34.6. And this is minus 39.6. Okay, so we want the sum of this, and now we have to take the product of this two and square of this also. So squaring, you can avoid the sign. So any one of you have done, then please give me these answers quickly. Have anybody done it? Okay, so the table I have given, you have to write and calculate that all the table. Okay, and unmute yourself and then tell me as you are ready. Summation x is minus 0.3. Summation y is 0. Sri Shailendra, you can unmute yourself. No, you cannot have the two values. Summation x and summation y is going to be 0. Is that okay? So what about the others? Are you getting these values? So we get here, this term is going to be 0, this term is going to be 0. Okay, so both these terms are going to be 0. What about the summation is x into y? So we are interested in this row. So we want all these values. So summation x has gone 0, summation y has gone 0. Now we have to calculate this table, and then you have to give me these values. Okay, so we can calculate this as, see what you'll be having here. Sign we can decide directly. So it's going to be minus. This will be minus. This will be minus. Going to be minus. This is minus. This will be minus. Here also we'll have minus. This term is going to be minus. This minus and this minus. So all the terms you'll have minus actually. Okay, and so the final sum will be also minus. Now find out what this is going to be. So it is going to be 21.6 into 18.4. So what is going to be? 397.44. Then square of this comes immediately. So 31.6 square. So we can have this is 466.56. Hope you are getting the same terms. 18.5 square. Okay. So what we get here? 338.56. Again, 18.6 into 18.4. Grade 6.44. So is there anybody who got the answer or who got this table completed? Going to be 345.96. This is 37. And 16. So have you got this table completed? Summation xy, you got 7968.6. Okay. This is what do you got here? 7968.4. 7968.4. What about summation x square and summation y square? So once we are ready with this term, so this is going to be 0, this is going to be 0, this is going to be 0. Okay, and hence after this calculations, what we have? We have r is equal to. So what will be having r is going to be see, it is going to be n times summation x y. So we have here n times minus 7968.4 upon. Okay. So what we have seen, this term is 0, this term is 0, so this is going to be 0, this is going to be 0. So square root of n times summation x square. So square root of 10 times summation x square and square root of 10 times summation y square. Okay, so what is the value of summation x square? Anybody got summation x square? So if you are able to get summation x square, then we are able to solve this problem. Yeah. So what is the value of summation x square? Yeah, summation x square is 8752.36. 8752.36. Okay, so it is 8752.36. Okay, so that's great. We got summation x square here. So it is 8752.36. Yeah. Now we have to look for what is the summation y square. Again, this will be a positive term. Okay. So we'll have this will be also a positive one. So what we are adding summation y square. 0.36 is as good as 0.4. So what we have summation y square. On calculate fast. So that's why I have told you to be ready with the calculators. Okay. What is the value Pakshal y square? Tanvi, Adesh, Rudransh. Yeah, we got the value from the Rudransh 7346.4. Okay, so 73 good 7346.4. So we got 7346.4. 7346.4. So we got this value of y square. What is that? Will be having 7346.4. Okay. So now we have the calculator, so we can easily calculate this value. And hence calculate this value. What is the value of r? So now we got all the values here. So again, it will be easy. So root 10 will become 10. This 10 will cancel. So it is going to be 7968.4 upon root of 8752.36 upon square root of 7346.4. So obviously this value will be negative. But remember that this value will be greater than -1 and less than 1. So what is the value you got for r? So who got the value of Adesh, Pakshal, Rudransh, Ishika, Anvi? Okay, so we got, yeah, Kalyani got the value minus 0.9937. Okay, so the value we got, great. So all of you got the value now, great. Yeah, so it is going to be minus 0.9937. So we have the value r is equal to minus 0.9937, and that's what is the coefficient of correlation. So is the coefficient of correlation between x and y. Okay, so you can see this is how we have to solve the problem. So now you got the idea about the table. Okay, so using this table, you have to fill this all entries, and then once you get this all entries, you are able to calculate their summation. So most important thing for us is this row of summation. Okay, and once you got this row, okay, we are able to get the value of r, and mostly the value of r, you can see the three values, these three values we are going to use. Okay, so xy, then we have summation these terms and the square terms. Okay, so these are the values we are going to use, and then we get the value of r. Okay, so now do you have any doubt in this example?
No, sir.
Yeah, that's great. So that's why here, as I told you in the message, if you use a calculator efficiently, then you will able to save the time. Okay, so this was the first example, so it took us time, no problem. Okay, but as we practice with the more examples, it is going to take less time, and we should use our calculator efficiently in these cases so that you can get the answer easily. Okay. So that's great. Okay. So that's good that you don't have any doubt here.